G'day, welcome back to a pickaxe ProtoPlatform tutorial video. Again, we're using the ProtoPlatform to show you what it's capable of doing with some different components. In this video we're going to have a look at a little accelerometer. This one comes from SparkFun, and I'll show you the website in a tick, but first I'm going to show you how I'm going to connect that to the board. So we can put that anywhere on the breadboard, remembering that down through the centre isn't connected to these two sides. So I'm going to lay it over this side, except all the wires are going to need to go in here. They can't go into this section, so plug that down there. Now this one's quite easy because it tells us exactly what the connections are that need to be made. I just had a quick look at the data sheet, and the recommendation was that you use a 1 microfarad or 0.1 microfarad, I think it was, capacitor across. I'll just quickly check that so I don't tell you the wrong thing. Yeah, 0.1 microfarad capacitor across the voltage to the ground pin. So first thing I'll do is I'll put that in, and that's just going to filter some of the noise out. So if there's any noise coming back from the power supply or something like that, that capacitor will help out and help assist with that. If you don't have it, I wouldn't worry about it. It probably won't matter. Next one is the power, so I'm going to connect the power down to VCC, and I'll plug that in there to keep it out of the way, nice and tidy. And then I'll use my blue to go from the ground and take that down to the ground over here. So I've got the power supply going to the accelerometer now. We don't need to worry about ST, that's for self-test, and that's if you want to check that it's sort of calibrated or something like that. I'm not going to do anything that fancy today, so we're just going to have a bit of a play with the graphs that I looked at on serial chart, like I've showed you in the last few videos. So I'm going to get the, we'll start with the Z-axis, and I'll go with a green lead and plug that in, and I'm going to connect that. I'm still going to have my serial data going out through pin 19, P19, so I'm going to start at 18, then I'll go with my, what's next, my Y axis. I've actually plugged that into ST accidentally, so just bring that down one. So that's Z, Y, I accidentally unplugged that one, not going very well, and then plug this in on there. X, so I got ZYX or XYZ, and then I'm going to plug them into 18, so 18, 17 and 16. Alright, so that's all we need to do with the connections there. Now the data sheet recommends, well, it suggests that the accelerometer only likes voltages of 3.3 or a bit lower. So I would recommend, if you're going to power it with batteries, rather than using three AA batteries, just use 2 of them, so you're getting around about 3 or 3.2 volts depending on how charged your batteries are. So the recommendation is that you take one battery out, maybe put a jumper across there, like an alligator clip or some sort of a blank battery or a flat one or something like that, or otherwise use some sort of a 3.3 supply. But I know it does work with a 4.5 because I accidentally tested it without checking the data sheet first. So we'll have a quick look at the screen now. This is the accelerometer that I'm using. It came from SparkFun Electronics, ADXL 335, and the data sheet is down here. So you can have a look at the data sheet yourself. It's actually here. I've had a bit of a flick through that, and that's where I found out that I should be using the 0.1 microfarad capacitor on the power supply to decouple that and filter out any noise. And then it talks about using voltages other than 3 volts. So it's not 3.3 actually, it says that it's tested at 3 volts and can go from 1.8 to 3.6. So 2 AA batteries would probably be the best bet to get some good results with this little device and not to damage it. In the pickaxe program, much the same start program here, I've just changed these symbols to be Z-axis, Y-axis and X-axis, and they're the 3 pins that we've connected in the video on the hardware. And then I've got the symbol baud rate the same as we had before. We've still got the frequency at M8, and these symbols are memory variables, and I haven't talked about bytes before, but if we go to simulate and just pull this across and go to Word, can we join them? No. Used to be able to join the two, but maybe, that's in the debug, so I can't show you that. But there are 2 bytes in any word, B1 and B0. Those 2 bytes make up one word, so you can't use B0 and B1 if you were going to be using word 0, because those 2 make up a word. So a byte is a number between 0 and 255, and a word is 256 times 256, whatever that equals, 6,500 and something. So yeah, a word's much bigger storage variable, but for what we need, we only need 256, so we're going to use bytes. And down here we've got read ADC from the Z-axis into the Z memory, which I've called Z read, and the same thing for Y and X. And then out here, and this is probably important, if I'm trying to get this data into the serial chart program, it needs to be comma separated. So what I've got is I've got the Z read value, and I've got a hash in front of it so that it's outputting in, I think that's in decimal format, but couldn't be exactly sure on that. And then in between I've got 2 speech marks with a comma in between, so that's actually outputting a comma between these values. So between the Z and the Y there's a comma, and then between the Y and the X there's a comma as well, and that's how the serial chart picks up that information. So every line, there's 3 different values on each line which have commas separating them, and then the next set of values is on the next line down, and this 1310 is, you can also use a carriage return, I think CR or something like that, but I always just use 1310, and that means that just starting a fresh line every time, rather than continuing to write across. It's essentially like pressing enter on your keyboard. So I've already programmed that, so it's already in the microcontroller. So we'll go to the serial chart program, and I'll see what I can do with my video. I haven't tested my video editing software yet, but hopefully I can show you both happening at once. So when I press play here and turn my microcontroller on, you can see those 3 lines running across the screen, and that's because I'm not touching my microcontroller or the accelerometer at the moment. But when I pick it up, you can see them move a little bit, and if I tip it to the side, you can see that the blue line is, I think, the Y-axis. If I tip it back and forth, can't really think what these axes are. I guess that one's the Y, and the blue from before was the X, and the Z is the red that's up the top. And if I shake it, so shake it up and down, you can see the red's the one that's moving, and shake it back and forth, that'll be the Y, and side to side, you can see the blue one's the one that's moving the most. Now there's always one G pulling on one, so one unit of gravitational force pulling on the microcontroller at one time, or the accelerometer, and that's why the red line's higher than the blue and the green. Really the blue and the green should be at the same height, and I think that's just because the battery leads are holding this board up a little bit. But if it was flat, the blue and the green would be on top of each other like that, and the red one is a bit higher. But if I turn the whole board upside down, you see that the red goes down below, because it's saying essentially that's -1 G at the moment. And you could get the pickaxe chip to be doing some calculations to give you, rather than these raw values, you could get the pickaxe to do some calculations for you and give you some G-force values. So thanks for watching this video. That's the ProtoPlatform using an accelerometer, and being able to see some of that data using the serial chart software. Cheers.